The hotel industry today requires systems that can be efficiently manage booking, payment processing, and room availability in real time. However, traditional centralized systems often face challenges such as low performance when many users access the system simultaneously. They may also experience synchronization issue and are vulnerable to a single point of failure if the main server becomes unavailable. To overcome this limitation, distributed computing can be used to improve scalability, support concurrent processing, and increase overall system reliability. Therefore, this project focuses on developing a distributed hotel management system by applying key distributed computing concepts and techniques. The main problem is that traditional centralized hotel system may struggle when many users access the system simultaneously. This can lead to performance issue, data inconsistency during concurrent transaction, and service disruption if the survey fails. Therefore, a distributed hotel management system is proposed to improve scalability, reliability, and system availability.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Ahmad bin Abidin. My metric number is 082866. And I will talk about the system design overview. System overview. The system to manage hotel operation across multiple server, while it ensures the scalability, availability, and consistency. Besides it also allows the hotel staff and customer to search for room, make reservation, and cancel booking, and also check room availability. The system has three distribute nodes, which is node A, node B, and node C. Node A is the main booking server, and the node B and node C is the replica server. The system has 5 main components, which is client process, request handler 3, naming service, replica manager, and log manager. This part is about main component. The first main component is client process. The client process represents hotel staff or customer that are accessing the system. The function of the process is to search, update room, make reservation, cancel booking, view booking details, and check room availability. Now for the second component is request handler thread. Each incoming request is handled by a separate thread. The function is to process multiple requests concurrently, improve response times, support high user traffic, and prevent blocking of other requests. For example, the customer A is booking room 101, while the customer B is checking the room availability, and the customer C is cancelling the reservation. All the requests from this customer can be processed simultaneously using multithreading. Now for the third component is naming service. The naming service maps human-readable resource name to their corresponding location. For example, the room 101.hotel.com is not A, room.202.hotel.com is not B, and booking.bk001.com is not C. The function of it is to resource identification, resource lookup, and name resolution. Now for the fourth component is replica manager. The replica manager synchronizes booking record across the distribute nodes. The function of it is to propagate updates, maintain data consistency, recover data after node failure. For example, booking will click on node A, and then it will be replicated to node B and node C. Now for the fifth and the last component is log manager. The log manager will record all the booking operation. The function of it to track update order, to support consistency checking, and to facilitate the recovery after failure. The example of the operation is room reservation, booking cancellation, and the customer check-in and check-out. Process and communication model. The model follows the multi-threaded server model. When multiple users access the system simultaneously, a separate thread will be created for each of the requests. Now, communication method. The communication method has 3, which is client server, client to server, server to replica nodes, and server to naming service. For the client server, The communication happen when request or response message. For example, when the user use the search room or booking a room. Second, for the server and to replica nodes, it happen when update propagation. For example, when they want to make a new reservation or to cancel a booking. Third is server to naming service. The communication happen when they are looking for some resource. For example, for room information lookup. This has some benefit of it, which is support concurrent users, faster response time, better scalability, and improve the resource utilization.
Assalamualaikum and good morning everyone. My part is naming architecture. My naming system architecture for our distributed hotel management system. The naming service is responsible for mapping human readable resource name to their corresponding location in the distributed system. This allows user and system component to access resources using meaningful name instead of physical address. For example, room 101hotel.com may be mapped on node A. Room 202 hotel.com may be mapped to node B, and booking BKB code 001 hotel may be mapped to node C. The main function of naming service are resources identification, resource lookup, and name resolution. By using naming service, the system becomes easier to manage, more organized, and more scalable as the number of hotel resources increase. Structure naming versus flat naming. In this project, we compare two naming approaches, which are flat naming and structure naming. Flat naming uses simple identifiers such as RM101, GST 001, and BK cost 001. Although this approach is simple, it does not provide information about type of category of the resource. Structure naming use hierarchical name such as room 101, guest 101 hotel, and booking 101. These names clearly indicate the resources category and make the system easier to understand. We selected structure naming because it provides better organization, improve readability, support hierarchy, resource management, and allow the system to scale efficiently as more room, guest booking, and staff were added. Comparison and selected approach. This table compare flat naming and structure naming. Flat naming provide shorter identification and simple lookup mechanism, but it has lower readability and is more difficult to manage when the system are grown. On the other hand, structure naming provide meaningful resources, name better organization, and easier implementation while maintaining good scalability. Based on this advantage, our distributed hotels management system adopt structure naming as the primary naming approach. In conclusion, the naming service help resolve the source across distributed nodes, while structure naming provide a more organized, scalable, and user-friendly solution for managed hotel resource. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Bernardin. I'm entry number 079398. I will present about replication and consistency. Okay, for this, the database replication is managed using the hotel replica class. Inside this class, the update bracket method synchronize room availability across the list replicates to ensure system reliability. When an update happen, the database receives it immediately with zero delay. However, the backup database receives the same update after 3000 million second delay to simulate real-world network latency. Even with this delay, both database will store the exact same value once synchronization is complete. This successful demonstrate eventual consistency. For this point, this distribute hotel management system consists of hotel booking service, a naming system, and replicated database. Client requests are the process through separate booking and payment treat to handle multiple operations at the same time. The naming system resolve service addresses for communication, while data is synchronized between the main and backup database. If the backup server fail, the system use a Boolean variable to detect it and stop sending update and bring backup hotel database fail. However, the system does not crash and continue using the main database, proving that it has strong fault tolerance and high availability. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Benadin. I will present about simulation. Okay. Saya akan terangkan sedikit tentang coding dalam segmen ini. Okay, first sekali kita tengok berkenaan dengan syarat hotel data ni. Okay, this class store the shared hotel data used by all service in the system. Okay, the variable available room, okay, represents the number of available hotel room. Okay, then hotel has 20 available room. Okay, since the variable is shared among multiple tree, a booking service access the same information. Okay. Second, about process tree model. Okay. Okay. Class hotel process extend tree. Okay. This class simulate hotel service using multithreading. This tree represent independent service such as booking, booking service or payment service. Okay, the system use concurrent processing so that multiple hotel operation can run simultaneously. Okay. Okay, next berkenaan dengan naming system. Okay, this component simulate naming service similar to DNS. Okay, instead of directly accessing an IP address, service can be located using logical names. Okay. For example, booking, kita dapat tengok sini booking hotel.com ni, payment untuk payment dan untuk tempahan bilik lah, room. Okay, dan seterusnya nurture consistency. Okay, replica update untuk simulate database replication. Okay, ini adalah concurrency consistency. Okay, government system. Okay, naming system untuk nurture consistency, sequential consistency, and high concurrency test and not failure in simulation. Dan terakhir sekali, okay, kita akan run. Kita akan tengok output yang akan keluar lah. Okay, tempahan. Okay, hotel processing. Okay, booking hotel. Okay, service. Okay, not failure simulation. Okay, buka hotel. Okay, booking service. Ini adalah output lah. Output berdasarkan semua coding dari sini. Okay. Sekian, terima kasih pada saya.
My name is Nur Aina Mitamari. My ID number is 081560. So for this project, I take a role which is the system integrated and the tested. My responsibility was to integrate all distributed systems into one application and perform system testing under different snaps. In the testing result, all modules were executed successfully, including process tree simulation, naming system resolution, invention consistency, sequential consistency, high concurrency testing, and node failure simulation. Based on the testing, the system was able to execute multiple threads concurrently while maintaining data consistency. The result also show that eventual consistency provide better scalability, while sequential consistency ensures stronger correctness and synchronization. In addition, the node failure simulation demonstrate that the system could continue operating even when one replica node become unavailable, which show fault tolerant scalability. In conclusion, all modules were successfully integrated and tested. The distributed system achieved the project objectives and demonstrate important distributed computing concepts such as scalability, consistency, and reliability.
This project successfully developed a distributed hotel management system using key distributed computing concepts such as multithreading, naming system, data replication, consistency model, and fault tolerance. This system was able to handle multiple concurrent requests while maintaining accurate and consistent data. Our evaluation also showed that eventual consistency provide better scalability and performance compared to sequential consistency in high concurrency environment. In addition, the node failure simulate demonstrate that the system could continue operating even when a replica become unavailable. Overall, the project achieved all of its objectives and demonstrate how distributed computing can improve scalability, reliability, and availability.